Good morning, CCS. This is Mr. Boolsen, and I'm just here to teach about a new lesson in math. And we're starting a new unit, so we're finished up with fractions, but we're still working a little bit with fractions today, and we're kind of transitioning to a new thing called decimals. Now, decimals are an interesting system that have been made up designed by mathematicians to speak about things over 10, so 1/10 of something. Now they also work for things over 1/100th and 1/1000th and it goes on and on and on and on and on. So really the decimal system is a interesting system. Now our mathematics in most of the world, I think basically all of the world now, uses 10 as a base number. It's called a base 10 math system. Now there have been other math systems that use 6 or other numbers, but the base 10 math system seems to work the best, and as such has been adopted basically worldwide. Now this is quite important for understanding, but we're going to start just with the 1/10. So 1/10 is a very important fraction in a sense because it does lead to this decimal system. So we don't get further. Before I get ahead of myself, we can show 1/10 in a few different ways, right? As we've learned, we say this is 0, and this one over here is 1. We can say that 1/10 is right here, right? And then over down in this shape, we could also say that this is equal to 1/10. Now let me just grab a bigger marker so that I can see this a bit better. This is also equal to 1/10, right? There's one part of 10. Now these parts might not be as equal as perfect, but I drew this myself, so that was pretty close. So yeah, it's one part of 10 is the idea that you get. Now mathematicians, as I was saying, have made a different system to write this that doesn't involve like a fraction. So we could say that 1/10 is like this. We can write it like this. 1/10. And this is also equal to 1/10. And this is just a decimal, so it's 0.1. And that's equal to 1/10. Now if we say 2/10, right? 2/10 is written like this in the decimal system. That is 0.2. And 3/10, if any who can guess what 3/10 would be? Well, it's going to be 0.3, and so on, and all the way up till we get to 9/10, right? And then you can say 0.9. Now this 0 here is quite important. What we're saying with this 0 is we're saying that we don't have a whole number. We have a portion of a number, just like with a fraction, right? This is just saying that we have two parts of 10 that make up a whole. So in our math, 10 equals a whole. So when we get to 10 of 10, right? When we write 10 of 10 in regular fractions, what we're saying is that equals one whole. And in decimals, or in regular mathematical notation, that is also just equal to 1. You could say 1.0, but really just 1. That's quite interesting and important to know, and we can represent decimals just as easy as we can fractions on a number line, which we've used before, right? So if we say this is a whole over here, or one whole number, a decimal can be found easily. So if we want to find, let's say we want to find 0.1, we'll just go here. This is where 0.1 is, and 0.9 is going to be over here, and we can just think of it as 9/10, right? That would be where you'd find it, and you just say 0.9. And if we wanted to find a different one, let's say 3, we just do it here, 0.3, and so forth. So really, this is just a different, more efficient way of writing out tenths of things, and it is used a lot in regular life, especially when you get to money. But we'll get there later. So the next big thing, as I said, was that decimals do not only deal with tenths, they also deal with 100ths. So let me move over here. These are squares divided in 100ths. And so if I color in, right, a section here, let's just say that section there, what would we say in fractions? In fractions, we would say that I've shaded in 1/100th. Now, in decimals, what would we do? There is a decimal way to do it. Well, we can't just say it's 0.1, right? Because that'd be wrong. That's saying in fractions, that's saying 1/10. No, in fact, we have to say, and 1/10, right? What's bigger, 1/10 or 1/100? Well, 1/10 is actually bigger, right? Because there's the portion is less. It's cut up into less pieces. So we have to show in our decimal system. Oh, I'm making lines everywhere. We have to show that in our decimal system that we have less, or it's a smaller number. So in fact, it's not this. Wrong. We have to say 0, right? It's less than 0. It's not a whole. Point. It's less than 1/10, so it's not in here. And here we write it 1. Now, in this area here, I've always thought of it myself as kind of a 10th spot. This is a 10ths spot. And over here, this section, in my mind at least, has been the 100ths spot. So, yeah, that's kind of how that works. Now, if I was to draw in 2, now that we've figured out that 100ths are drawn a second decimal space later, so if I was to draw in 2, what would I show here? Well, what's the fraction? We know that that is 2/100ths. And if we're dealing with decimals, we remember we have to have 0, and now we're going to, for 100ths, we'll have something filling in here. We have 2 digits now instead of 1. And what you can actually notice, right, is that this kind of gives you a clue on how many digits you'll have in your behind the period, or behind the point, or the decimal is what it's called in math. And so this is actually equal to what in decimal system? Well, it's 0, we know that, and it's not a 10th, right? But it is 2, right? 0.02. So it's really important that we remember that we're dealing with a 1/100th or 2/100ths, that it'll be 2 points backwards. Now, if we wanted to find 3, what would we draw on here? Actually, how about we go to 9? I'm just going to cross them out, right? If 1, 2, 3, 4, 5, 6, 7, 8, 9. So this, we know, would be 9/100ths. And to write that as a decimal, we would go 0.09. Now remember what happened when we got to 9/10ths, right? It was 0.9. And when we got to 10/10ths, we actually 10/10ths equaled 1. Now, you see how basically this number, once it got to a full number, so basically you could think of this as now adding one more point, right, onto that, and then you'd have 10. Really what you have here is kind of this. You have a dot here, and you have 10 almost, or a whole. You have 10/10ths, in a sense, and that makes a whole. The dot, the number, gets moved over to here. It's in a way, and this might be a little bit, the way I'm explaining this might be a little bit confusing, but I'm hoping that you get it. Once you get to 10/100ths, something similar happens. The number actually moves over. You start working in the second block. So 9/100ths, right? 9/100ths gives you this. Well, when you get to 10/100ths, 10/100ths actually looks like this: 0.10. Now, this might look strangely familiar to you guys when we're dealing with tenths, and that this would be 1/10, and that would be 0.1, right? And these are quite similar, in fact, that there's 0.1. Now, you could even think that there is a 0 here, actually. Technically, we are saying the same thing. These are equivalent. And you will notice here too that these, if you think about it for a little bit, these are equivalent fractions as well. That's right. So you have 10, and you say that that equals 100. If you were trying to find 1 over 100, well, you would just times this by 10, times this by 10, and that would give you an equivalent fraction. See, these are, in a sense, equivalent. And they are in the decimal form. This means the exact same thing. Now, so that's kind of a cool feature. Oh, sometimes, it just doesn't want to erase. And I wonder why. Yeah, so, and it keeps getting kind of cooler from there. So now if I give you a number like 11, so I want you to find 11. So that's 1, that's 10, right? Because that was 9 with 1 left. So this is 11. So we now say this is 11 out of 100. And in our decimal system, if we wrote that for 10 of 100, what are we going to say? For 11 of 100, well, it's still not a whole, 0. And then we know that it's 1, right? And then we just put the second one here. And that says 11 out of 100. Now, if I wanted to show, I'm not going to draw it in, but 35 100ths in decimals, I'm going to just do it like this. This equals 0.35, right? And that is the decimal way of writing 35 and 100. And if I wanted to say 89 of 100, that's going to be written like this, 0.89. Yeah, so I hope you basically get that idea, like how to convert it, right? Especially these ones, I think they're kind of simple. Once you have a 35 over 100, you say 0.35. You just put this 35 behind the 0. And you could consider this number, this area here is where you put the wholes, the whole numbers. This is a full number right here. And these are the parts. These are parts of a full number. So it's kind of, it has a lot in common with fractions, right? That this is the full number here, and this is the part. And when you get to 10 of 10, right, that gives you a full number, nothing behind here, right? There's no other parts. And we'll get into more interesting things. And yeah, here is the same thing, right? That you have 89 parts of 100. And so you don't have a whole yet, right? You're not one whole. But so you have 0 here, and then you have 89 parts of the whole. And yeah, that's like the basic way we can show this. And now we can go and look on a number line. So you'll be dealing with a bit of these, I think. This is a 100th number line, so it's a pretty big number line. You can see all these little small ticks, those are tenths. So this kind of helps to illustrate, right, that in each 100th, right, there's 100 in total here on this line, and this is you could say this is either 1/10, or you could say it's 1/100th. Either way, it's written like this, 0.10. Now when you're dealing with here, right, if you have less than 10, you're going to be saying, so say I crossed here and said, what is this one? Well, you say 1, 2, 3, 4. Well, are you going to write that like this, 0.4, or is it going to be like this, 0.04? Well, if we look on here, right, this is actually 0.40. And is this one bigger than this one? No, remember that on a number line, this is the biggest, and this here represents 1 whole. So when we're here, we're below even 1/10. Sorry, actually, this, I should have written that as 10 100ths, my bad. But yeah, so 10 100ths or 1/10. Now this one here is wrong too. We can't say that. That's wrong. This is actually correct. This is 4, you could say in a fraction, this is 4 100ths, right? So these little ticks make up, all the ticks together are 100, and there's 4 of the ticks up, right? 1, 2, 3, 4. We're on the 4th tick, and so it's 0.04. Now, if we're over here on this one, right, we would say 0.21, and that would be equivalent to 21 over 100. So yeah, this is the basic decimal system. If we go here, right, it's 81, oh no, 0.081, and that is equal to 81 parts of 100. Now, I did say that we were going to deal with this in the real world. Now, I'll just take this for a moment, that you'll also notice that this same 10th system is used in our everyday lives. When I talk about 1 cent, 1 cent, what am I saying? Well, 1 cent is, what's that worth? Well, that's worth, how many cents are in a dollar? Well, there's 100 cents in $1. That equals $1. Now, yeah, so that's important to know, that 100 cents equals $1. And if we have 1 cent, that is equal to 0.01. Now, you might, if you have ever been to a coffee shop or like Tim Hortons, you might have seen that your parents paid something like $2.66. It would say something like that. And maybe that's for a coffee, a large coffee at McDonald's or Tim Hortons, wherever you go. And this, what is this referring to? Here, this is referring to 2 whole dollars. That's referring to 2 whole dollars. This is referring to the number of cents, right? And you can see, I hope that you can see that this is very similar to our, this is using our decimal system that we just learned. This is really saying that you have, in a way, you could say you have 2 and you have 66 100ths, right? That would be your dollars. But it's easier to write like this than this. As you can see, this gets to be all messy. So you have this nice neat thing, and you just say that there's 66 parts of another whole dollar. And these we call cents. And cent, like in, if you know your French, cent means 100. And so our monetary system is a base 100 system. And if you had a quarter, right, a quarter is 25 cents. And that, if you look on a dollar scale, right, that would be $0.25. So yeah, you can see that this comes up a lot in our daily life, that we have decimals. Now, decimals get used on a lot of other things that are more, a bit more important than what I'm showing you here. But, I don't know. Actually, money is pretty important, and we deal with it every day. And so, yeah, it's quite important for us to understand how to use it. Now, I know that this has been kind of a long video, and it's a lot to take in. So if you need to, I would suggest going back and listening again, spending a bit of extra time looking into this, because maybe it's a bit harder to wrap your mind around how this decimal system works. I hope the video was helpful, and I hope that if you have any questions, you can always shoot me a question on Google Classroom through the private messages, or send me an email. Anyways, guys, thanks for watching, and I hope you enjoyed the video.